In this video, I'm going to show you how to import the required part files for machining of the night project. I have Canvas opened up on my screen, and I also have a session of Mastercam opened up on my screen. I have a blank session of Mastercam. The units are set to inches. I'm going to start by importing these files here. I've already downloaded them. I've created a working folder. You can see that these files have already been downloaded into this folder. So inside of Mastercam, I'm going to go to File, Merge. I'll navigate to my working folder. So I'm going to go to C. Here's my working folder. And I'm going to start by importing the rotary table, the HRT 160. So I select it, I hit Open. It'll take a moment to open up. And once I open it up, or once it's imported into Mastercam, I'm going to place it at its default location, so I'll just select OK. And then right-click Isometric. And you can see it's not in an orientation where I can easily see what's happening on this side of the rotary table. So what I'll do is I'll rotate it, just holding my scroll wheel down, and rotate the view. I'll set it up so that it's easier to see once I place the part inside of the jaws. And for the view sheet, I'll right click on the view sheet, I'll rename it, I'll call it ISO view, and then right click again on it and save view sheet as bookmark. So now, after I move, or if I reposition my view, to get back to that view, I just double click on the view sheet and it's in a more manageable state. So we brought in the HRT 160. I'm now going to bring in the part file. I'll go to File, Merge. This time I'm bringing in the night for import. I'll select Open. And it's already placed where it needs to be. So at this time I'll hit the green check and I'll go back to the project page. So once we import the parts into Mastercam, we are instructed to create a solid model to represent the material and place it relative to the night model that is already merged into the Mastercam file. Reference the material prep drawing on the previous page for 4 dimensions. Scroll down. I'll go back to the previous page. And here we're being told that the material is going to measure 6.65 inches overall length. And then the OD will be 2.5, and then there'll be a reduced diameter that we hold on to with the jaws. That's 1.5 inches in diameter. The length of the 1.5 diameter piece is 2.5. So I'm going to use this information to create the material representation around the part. I'll go back to the previous page. And in this view, you can see the material in the jaws of the chuck. The material, or the part I should say, is embedded in the material. So I'm going to build this material representation. I'll go into Mastercam. I'm going to make my level manager visible. I'll go to View, Levels. And these are the levels that were created when I imported this geometry. I'm now going to import my default levels for this class. So right click, Import Named Levels. I'm going to navigate to my project folder. Here are my default levels. Select Open, and you can now see those levels in my level manager. I'm going to make the material level the active level, and I'm going to create 2 cylinders that are going to represent the material. And if you look at the representation here, you can see that the origin is on the base of the part, which will also be the right side of the 2.5 diameter piece of material. So back inside of Mastercam. I'm going to change my construction plane so that the XY plane is planar with this face. And if I go up to my plane manager, I'll go to View, Planes. The current construction plane, the XY is not planar with this face, so I'll just View. So at this time I'll go to the front construction plane. You can see that the XY plane is planar with this face. And I'm going to draw two circles on this plane. I'll go to Wireframe, Circle Center Point. I'll let my cursor lock onto the center. In the diameter field, I'll type in 2.5. That information is coming from the material prep drawing. I'll select the blue check, and then I'll draw a second circle. Once again at the center. This time the diameter is going to be 1.5. I'll select OK. If I go back to the blueprint, the length of the 1.5 diameter portion of the material is 2.5 inches. I'm going to extrude the 1.5 diameter circle, so I'll select it. I'll go to Solids, and I'll go to Extrude. It brings up the wireframe chaining dialog box, so I'll need to reselect this circle. I'll select OK. And I'm going to extrude this for a distance, go back to the blueprint, 2.5 inches. And it's important that you do not merge it to the existing solid. So I'm using Create Body. I'll select OK. And you can see that the extrusion goes back into the jaws of the chuck. I'll go to my level manager. I'm going to make the solid model invisible. I'm going to extrude the 2.5 diameter length. I do not want it to be attached, or I do not want it to merge with the part file. I want it to merge with this 1.5 diameter section. So from here, the overall length is 6.65. The current length is 2.5. So we need to add the 2.5 length will be equal to 6.65 minus 2.5. Extrude. Select this circle and selection. I need to change the direction. For the distance, 6.65 minus 2.5. I'm going to add boss. I want to join these two pieces. I'll select OK. And now if I select the material representation, you can see that the material, these two cylinders are joined together. If I change over to a translucent view and I make my part level visible, you can see the part inside of the material. I have enough material so that the entire part will clean up when we machine it. So from here, this would be a good time for me to save my work. I'm going to save it to the working folder. I'll call it Night Project. Select Save. These two circles, I'm going to place them on the solid support geometry level, so I'll select the two circles, right click, change level, and then I'm going to move them to level 1. So I'll deselect use active level, change the level number to 1, and then at this time I can make the solid support geometry level invisible. I don't need to see those two circles. So from here, I'll go back to the project page. We've got our material representation in the file, and we're now instructed to create the coordinate systems that we need to use for our toolpaths. Create a new coordinate system and name it left side face. Reference the images below for origin, orientation, and location. The WCS is shown centered on the center line of the rotary table, which is also the center line of our part. X0 is on the right side face of the material as shown. So if I zoom into this picture, you can see that X0, the origin, is on this 2.5 diameter face. The x-axis is pointing along the center line of the part, also the center line of the rotary table. So from here, I'll go back to Mastercam. To create a new coordinate system, there's several ways that we can do this. I like to grab the coordinate system here. So hover over this coordinate system. You'll see your cursor change to a hand. Left click and drag your mouse away. And you'll see this gnomon appear on your cursor. I'm going to lock on to the center here. Left click. I'll need to change the orientation. And you can see that the X is currently pointing in this direction. I want the X pointing along the center line of the part, or the center line of the material. To rotate the X, or to get the X pointed in this direction, I need to rotate about the current Z axis. To do that, hover over the blue arc. Don't need to click on it. Hover over it. You'll see a number field appear. Type in -90 and hit enter. Enter again. I now have the correct orientation. You can see that the coordinate system is centered on the part. Let's give it a name. If I go back to the project page, we're instructed to call it left side face. In the name field, left side face, I have set as WCS, T-plane, and C-plane all checked. From here I'll select the green check. I can't see it, so I'll go to View, Show Gnomons. And if you expand this, I usually use T-plane, and I'll uncheck C-plane. From here, if I right-click Isometric View, not the view that I'm looking for. I would prefer to have this view as a view that I reference while I'm programming or creating toolpaths to machine the left side face of the knight. So at this time, I can create a new view sheet, plus sign, call it left side face, ISO, hit enter, and then I'll right click, set view sheet as bookmark. From here, we'll need to create 3 more coordinate systems. If I go back to the project page, we're now onto this step. After you create and place the left face WCS, you will need to create 3 more coordinate systems. One for the back face, one for the right face, and one for the front face. To create the back face WCS, right click on the left face WCS and select duplicate from the flyout menu. Then right click on the new WCS and rename it back face. So back inside of Mastercam, go to the Planes Manager. Here is our new coordinate system. We're going to duplicate it and then rename it and rotate it. So I'll start by duplicating it. Right click and I'll select duplicate. If I'm following the instructions, the first one that we're going to create is the back face. So rename the copied coordinate system. So right click, I'm going to go to rename, call it back face, and the back face will need to rotate the coordinate system about the x-axis. So I'll right click, rotate incremental. We're rotating about the X. I'll type in 90. And I'm seeing a different coordinate system, so what I'll do is I'll expand this, and I believe that's a preview for the new coordinate system. So I'm rotating at 90. Let's go back to the project page. we're instructed to rotate it -90. So go back to Mastercam, -90, hit enter, and then select OK. With the back face selected, hit the red equal sign, and you can now see the new coordinate system. X is still pointing along the center line of the part, but now Z is perpendicular to the back side of the part. And if I look at it from a top view, we're looking at the back side of the night. So from here, I'll go back to the project page. I'll go down to the next set of instructions. To create the right face WCS, right click on the left face WCS and select duplicate from the file menu. Then right click on the new WCS and rename it right face. Once you have renamed the new WCS to right face, right click on it and select rotate incremental. This time we're going to rotate it -180 or 180 in the About X field. This WCS will be used for the toolpaths that machine the right side of the night. I'll go back to Mastercam. I'm selecting the left side face again. Right click, duplicate. On the copied toolpath, on the copied coordinate system, right click, rename. Call it right face or right side face. I'm going to follow the instructions. I'll call it right face. I'll hit equals. It has the same orientation as the current left side face or the existing left side face. I need to rotate it 180 degrees, so I'll right click, rotate incremental. Once again, rotating about the x-axis 180 degrees or -180 degrees. I'll select OK. Now if I look at it from a top view, X is still pointing along the center line of the part, Y is pointing forward, and Z is pointing up. This is the coordinate system that we're going to use to machine the right side face of the night. So from here, I'll go back to the project page. I'll go down to the next set of instructions. It says to create the front face WCS, right click on the left face WCS and select duplicate from the file menu. Then right click on the new WCS and rename it front face. Once you have renamed the new WCS to front face, right click on it and select rotate incremental. Enter -270 about the X field. This WCS will be used for the toolpaths that machine between the ears from the front side of the night. I'll go back to the left side face and then I'll go to duplicate. Right click, rename. I'll call this front face. I'll select equals. Right click, rotate incremental. About the X, -270. Select OK. And now if I right click on my screen and select top, we're now looking at the front face. This will be the coordinate system that we use to machine between the ears on the front face. I'll go back to the project page. Inside of Mastercam, I'm going to go to an isometric view. Now we're seeing the rotation of the rotary. In reality, or on the machine, this will not rotate. The part and the chuck will actually be the items that rotate. So from here, I'll select isometric, file save, and we're now ready to start creating toolpaths.